Lights, please. All right, so we were talking about desktop versus server software last time, and we were talking about desktop having to focus on high performance for a single user. There's lots of available software, lots of available hardware, probably less proprietary because it needs to hit more of a general audience, and the cost needs to be low. So super fast, lots of software, lots of hardware choices, and needs to be cheap. Seems like an easy problem to solve. So now we take this over to the server side. What are we looking for from a server operating system? What are some of the things a server operating system might do? Like what differentiates a workstation, a desktop workstation, from a server, besides just the names?
What you're really connected to?
Okay. I'm not sure I know what you mean by most of that. And then you also had a dangling preposition.
This computer to a server.
Okay. I mean, yeah, I am talking about what that computer might connect to in terms of a server. Tell me about that server. What is a server? That's not going to cut it. Go ahead.
It's a server where all the files sit and it's file protected and everything's secure on the server, but all the workstations can access those files and edit them.
Okay.
No one from outside.
So one use of a server might be for centralized storage of files. Okay, that's one use of a server. What else might be a use of a server? That's it. That's the end of it. That's the end of it. Well, how many of you have ever used a web browser? Typed in www.google.com or a zillion other web addresses, right? Where do those come from? When you type in www.google.com, what are you expecting to get as a result? Pretty pictures on a page in front of you, right? Now, where did those pictures come from? Is that you have to be hooked into the internet in order to get those pretty pictures, don't you? So if you're sitting inside of a lead box and you have your laptop in there and you type in www.google.com, you're not going to get much, are you? Okay, so that had to come from somewhere. Well, it came from a server. What did that server serve you in that case? So servers kind of have dual meaning. We think about a server is a piece of hardware. It's a let's just say a powerful computer that's running an operating system that's probably a server-centric operating system, an operating system specifically designed for servers. But more importantly, the concept of a server, the word server dictates what the machine is being used for. So when we think about desktop operating systems and desktop computers, it's not just what they look like. The laptop and a desktop computer or an iMac, all these things are built to solve similar problems, right? They're built to solve that desktop operating system problem. Be fast for a single user at a single point in time, lots of software options, blah, 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 blah. Well, a server, besides it being a physical computer as well, of various, let's say, power, it also is running a piece of software, an operating system, that allows it to do server stuff. Serve information. So for instance, one of the things that might serve is files. Just generalistic shared files. What else might it serve? Well, we just cited an example. It might serve websites. Oh, what's a website? What does it mean to serve a website?
Directs you to where that website is stored.
Directs you to where that website is.
So basically, your server would direct you to another server where the website lives, I guess. Or
A lot of times they're just called web servers, right? Oh, here, let's say use that as a simple example. So a web server has some data storage, and that data storage is holding a bunch of HTML files, some images, and PHP files. And it needs to provide a way for these computers to retrieve that information. So running on this web server is a software application that's implementing something called the HTTP protocol. Usually the program is called HTTPD for daemon. Daemon is like a software-based server. So maybe this guy, historically, web servers are running on port 80. So it's listening on port 80, which is kind of like one of the phone numbers at this IP address. So a web server itself has an IP address. Okay, and at this IP address, there's a whole bunch of sub-addresses, a whole bunch of ports, front doors, if you will. Think of this as like a hotel. Here's the address of the hotel, and here's all the rooms in the hotel. Okay, one of the rooms is room 80. And when you knock on that door and the door opens, the dude inside is speaking the HTTP protocol, which is just a language. So on these PCs, we have a web browser. Whatever. Now this web browser knows how to open up a connection to a web server specifically on port 80. And the web browser, which is just a computer program, right? It knows how to speak the HTTP language. So it's going to go to this web server, which is a computer that lives at a certain address, a certain IP address, talk to it on port 80, so it's going to knock on that door where this software application is listing. That software application is going to open the door, it's called a socket connection, start babbling in HTTP. The web browser knows how to speak that language. And they're going to start talking back and forth to each other. So the web browser, if you typed in www.google.com, and just to kind of demonstrate this, if I come in here and I type in www.google.com and I put on the end of that :80, I'm specifying I want it to talk to port 80, even though that's the default. So you'll see that it comes up. That make sense?
How many ports are there?
Well, there's 1,024 that are reserved for the operating system, and then beyond that, it's size event. So probably 65,535 for most operating systems. Anything above 1,024, a user can just grab. You can create your own program that just says listen to port 4,000, something like that. Okay. So when I typed in www.google.com, it went through my internet connection, which is here at Concordia right now, through their DNS server. Their DNS server is a domain name service. So what it did is it translated google.com into an actual IP address. So it's as if I typed in the IP address here, which is like dialing a phone number. Okay, so what I just did here is it's like it's on your cell phone saying, call Mike Lippman. And then your cell phone had to look up Mike Lippman's actual phone number, and then it actually made a call to that phone, that server, on port 80 specifically. Okay? So the HTTP protocol, this is a program that's running on this guy that takes requests. So when my web browser requested a web page from google.com, what page did it request? Well, we didn't see it in here, but we definitely went to port 80 and we requested a page called index.html. That's the default web page. Actually, maybe it was default index.html. Let's try index. I doubt that would be it. This would be actually really funny. Most web servers, it goes to index.html. I wonder what the name of, well, not that important. That would work 99% of the time. So if I go to www.cuw.edu, that takes you to Concordia's main page. So Google must be using an interesting web server, maybe one they wrote themselves. So in any case, the web browser is going to ask for index.html, which is going to ultimately talk to, it's going to be, even though it's connected to this web server, the web server handed off that connection to a piece of software that lives on that server, this guy. That software is going to talk back and forth with the web browser and ultimately send the web browser a file that has links to where the images are and all that good crap. Okay? And then the web browser interprets what was sent to it and makes it show up as pretty pictures and that kind of crap. So just as this here, this web server down here, is a physical computer with a physical IP address, which uniquely represents it on the internet, this piece of software here is also called a server. That is, it's a piece of software that serves data, serves information in some way. Now, is there any difference between serving HTML file images and PHP files compared to our previous statement of a server OS as a centralized file storage? There's a difference between storing your files in a centralized location and then giving us access to those files. So what a web server is it gives us a format, a mechanism for requesting files using the HTTP protocol. So if I decide I want to, let me make this a little bigger. Telnet to www.cuw.edu port 80. Actually, I think it's a space 80. Okay, we're now talking to the HTTP server, and I think that's the first line we send. All right. I know I've done this on Google before. Well, there's an example. So we got a document has moved thing, so it yelled at us, but in any case, we see it served us some HTML code. So we talked to their web browser or their web server, and we got this page has moved to another page error. Okay. So what this web server software is, it's a mechanism for interacting with this file storage back here. So we have a centralized place to store files, and then a piece of software that manages how we interact with those files. All right, so another example of how we might use a server is for serving web pages. Well, if we have a centralized file storage, what are some different ways that we can interact with those files? So let's say that we have all of our school documents on a server somewhere, centralized storage. What are some ways we interact with those documents? Well, one way we've talked about a lot in here is Dropbox, right? Is Dropbox a server? Well, we have a client that runs on our computer. That's the client right up there. And that client's got to be talking to somebody. So somewhere out there, there's a Dropbox server that is running probably something called Dropbox Daemon, or some software like that, that knows how to talk to Dropbox clients and syncs data between the two of them. Make sense? So Dropbox would be one example. How many of you have heard of FTP? FTP is File Transfer Protocol. It's kind of like HTTP. FTP runs on port 21, is the default port. So FTP allows us to transfer files from the current location up to a destination. And we've looked at an FTP in here before, didn't we? See the running dog that Dane didn't like? Okay, that was an FTP client, kind of just like the Dropbox client talking to an FTP server somewhere, where I could see all my files. I can put files up there. I can take files down from there, drag them down. So FTP is a protocol that allows us to send and retrieve files, create new directories, that kind of stuff. Telnet, which runs on port 23, is another piece of server software that allows us to have shell access to a computer. So if I were to telnet into a server, I'd be sitting at a window that looks a lot like this, where I can give it Unix commands and do things. Kind of like I'm using DOS, but remotely. So that's what Telnet lets you do. Telnet would be another example of server software. And the list keeps going down, because these are Telnet FTP. The web server would be an HTTP server running on port 80. Those guys are kind of, standards. They've been around for as long as the internet's been around. Okay, so HTTP runs on port 80. That's why you don't have to type it into your web browser. Your web browser knows when you type in www.whatever.com, it's going to go to port 80 by default unless you specify to go someplace else. Okay? FTP also defaults to port 23. Telnet defaults to FTP defaults to port 21. Telnet defaults to port 23. Then we have the secure version of Telnet called SSH, Secure Shell. So that's the encrypted version of Telnet. We have an encrypted version of FTP as well called SFTP. Very inventive. Secure FTP. And the list just goes on and on and on. Every single day, we probably have somebody writing their own little server software like this to do something. That's how, the internet keeps evolving. If you've heard of a language called PHP, well, the PHP language is a web programming language, so you would have people who would define their own sort of kind of servers, if you will, in terms of the HTTP protocol. So they would write their own dynamic abilities that piggyback on top of a web browser's ability to already talk to a web server. That makes sense? And if you're in the 390 class, we're going to be doing some of that here in the next week. What's that?
Look at what PHP stands for. It's ridiculous. It's like something PHP.
It's probably a couple dudes' names, isn't it? It's a
No.
recursive name.
Yeah, so it keeps going and going.
Mm-hmm.
The last letter stands for.
Okay, so these are all examples of server software. So these would be applications that would run on a server. Now, don't these look pretty different than the applications we would run on a desktop computer? Desktop computer, the equivalent example of applications would be like Microsoft Word, Internet Explorer, Safari, uTorrent. Okay? Those are client applications, things that we would expect to find on a desktop computer, things that support the use of a single user using the machine at a time. Do you think there's only one user who is using Google's web server at a point in time? Thousands and thousands and thousands of users per second, probably. Okay? So, that server is not designed to make one person happy. That server is designed, and the operating system on it is designed to make lots and lots and lots of users think that they're the most important user in the world at all times. Because as Google searchers, we're not willing to wait extra time for somebody else to finish their search, are we? We'll go use Bing
No.
as opposed to waiting on Google. What if your search took 10 minutes on Google?
Ask Jeeves.
I'll use that. Yeah, ask Jeeves, or I'll use that. There's some Chinese search engine that's very popular.
Some Chinese.
There's like a B.
Yeah, I know what you're talking about.
No.
You know, I actually think that, I'm not 100% positive, I think I read somewhere. I think that Japanese one you're talking about is actually Google.
Oh, really?
I think Google owns that company.
It looks kind of similar.
Yeah, but I know exactly what you're talking about. So, in any case, and actually, I don't think it's Japanese. I think it's a Chinese server. Yeah, but I know what you're talking about.
I just was looking at it. And it was
Mm-hmm. So I think it's kind of the censored version of Google, as the government controls the flow of the web there to at least a decent extent. So the software applications we'd have running on a server computer, on a server operating system, are a little bit dissimilar to the software applications we have running on a desktop operating system. So we get back to what a server OS is. Designed to give we'll just say high performance to multiple users at a time. Maybe more proprietary. Why would it be okay to be more proprietary? We're not necessarily saying it is more proprietary, but it's acceptable for it to be more proprietary. If you go to the car dealership and you buy, I don't know, what, a Chevy Impala, something like that, that's a common popular car. Okay, everybody who has an Impala, if they have something go wrong, they can take it into the dealership and there's replaceable parts for it, right? And they expect to be able to get that replaced in a day or two. You know, it's interchangeable parts, correct? Okay, that's because there's a zillion Impalas driving all over the place. So they're all the same. They all use interchangeable parts. Well, Google's server could very well be a very proprietary piece of equipment made specifically for Google's needs. I mean, it could also just be a whole warehouse full of Dells or something. Who knows what Google servers end up, actually look like behind the scenes. But regardless, there could be a proprietary nature to it. But the difference is that when Google has something go bad, they go directly to the manufacturer. And they say, we need this replaced on this. So it's kind of like a Rolls Royce. a car that was custom built for somebody. You know, you're not just going to pull into the Ford dealership and say, yeah, I have a Rolls Royce and this part went bad on it. You wouldn't let somebody at a Ford dealership touch your car if you have a Rolls Royce. Because your Rolls Royce costs like as much as some people's like countries. So in any case, that's kind of the example where things could be acceptable to be more proprietary. Is there necessarily more software for desktop computers, or is the software just different? You might be able to make an argument that there's more software applications available for desktop, but I mean, I don't think it's by rule that that's the case. I think it's different software applications. The software applications for server operating systems have different goals. So possibly more proprietary. What about cost? When you're dealing with a server and a server operating system, is cost the number one concern? Probably not. You know, when you think about server class hardware, it's always more expensive than consumer class hardware. Why? Well, because if you're somebody who thinks they need a server to serve information, you're probably making money from somebody else, and you care more about reliability and performance than you care about the actual bottom line cost. Priorities are different, right? Not necessarily, there we go, fixed. Not necessarily low cost. Okay, now, so in this class so far, we've talked about the concept of operating systems at the high level, the different parts of an operating system. Well, now we have two separate kind of focuses, two separate design goals for an operating system. So just at the top level, if we're trying to provide a great end user experience for a single user versus a great end user experience for multiple users, just that one goal difference, how's that going to change your operating system? If you're writing a desktop operating system and you're trying to make it great for a single user at a time versus a server class operating system that's got to be great for many users at a time, what is that going to mean? What about memory? Let's talk about memory. Let's just go down the list. How might memory management differ? Well, how does memory management work on our generic operating system? Paging model, right? So when a file needs to be used, we load it off the hard drive into memory and it's now available, correct? Well, who requested that file? The one user who's using the computer. Well, in a server class operating system, who requested that file? Maybe one of 10,000 users, right? Well, let's look at the Google as an example. We'll just assume that their homepage is index.html. I really am interested in what it actually is. But let's just say it's index.html. How many people are requesting index.html every minute? A lot. Yeah, we rounded down, Skippy.
Round down a little bit.
Yeah, it's not a little bit. Not a little bit. It's a lot. So a lot of people are requesting that file every minute. Well, do we want to load that file separately into memory each time? Does that file dynamically change? No, I mean that's a static file. That's not something we need to process on a per user basis. It's something we just need to serve the bits of, give a copy of that to an end user for their browser to interpret, right? So we keep that in memory and it only needs to exist once. Well, what if we have, what would be a good way of, well, here, let's say that you have a single Word document on your laptop. And you and the person next to you want to work on that single Word document at the same time. Right off the bat, there are issues with doing that at the same time on a single laptop. What are the issues? One keyboard, one screen, one mouse. one Microsoft Word application. One computer. There's one computer, two people can't be doing the same thing at the same time. So the second you start multitasking, that is doing two things at the exact same time, you have multiple individual people who are remoted, even if it's local, even if we're at all these computers in this room and we're connecting to Concordia's web server, we're still remoting into another machine and using that machine through our console. Make sense? And we really rely on this in the real world. You got something good?
Yeah,
It was like 59 million hits per second.
59.4 million.
59.4 million hits per second. Okay, so that's a lot.
So little.
Okay. So, and we see this all the time. How many of you play either Xbox or PlayStation online? So let's take a popular game like Madden or something, or one of these Battlefield games where it's a multiplayer type of experience where you're playing in the same world as a bunch of other people. It would be an unfair advantage if your actions did not immediately impact other people's actions, right? So what if somebody else could run around the map and kill off everything, including you, before you were even aware that it happened, which I'm convinced that some people in those first-person shooters do.
Flag switch.
Because I just die instantly. It's almost always a headshot. So, but in any case, we rely on the server that is either Xbox Live or PlayStation's. What is it? PlayStation just called PlayStation Network.
Yeah.
Yeah. Okay. So we rely on that server to connect us to all the other people who are currently playing the game, and fairly divide up our gameplay experience. And when I say that, I'm saying as fairly as possible. Because there's all sorts of variables in there. Internet connection speeds being probably the main one, right? I mean, if you're on a dial-up internet and you're playing maybe Madden is less affected because it's not as fast-paced as a first-person shooter might be, but it's still fairly fast-paced. But certainly a first-person shooter, I mean, if you watch somebody who's skilled at those games, you see them ducking in and out from behind walls and stuff like that, and even a fraction of a second difference is a major, major deal in those kind of games, right? So if you were on a dial-up modem and somebody else is on a fast broadband internet connection, the concept would be that if they're getting an unfair advantage, you're wasting your time playing. Even if your skill level is equal to theirs or greater. Because they have time on their hands now, right? I don't care how slow of a runner I am. I can beat the fastest sprinter in the world if he's chained to the starting blocks and you give me like a week head start. And it's like a 100-meter dash type thing. I can beat him. If I get a week, I will beat him. Go ahead.
I know in COD a few times, Call of Duty, they try to match you up with people that are like the same internet speed as you.
Well, and that's kind of what I'm getting at is they have to take into account these things, and they have to come up with what is the most fair way, the most fairest way, most fairer. That sounds better.
Yeah.
Most fairer way of. Somebody's gonna watch one of these videos like out of context and like, I don't think this guy should be teaching in college.
We'll start a class yesterday.
Oh yeah,
70.
that was funny. Most of my classes are funny though, aren't they? It's at some level there's like something strange. Something strange happens in like every single class. It's kind of like the surprise, Spoilers. Brought to you by Nabisco. What was I talking about? Oh, yeah. So the people who wrote that server software had to figure out how can they make their consumers, the clients connecting to it, happy by simultaneously using the machine. And that's a far more important we might say gaming isn't as important as productivity, but the reality is when you consider your consumer base, it's far more important, correct? The number of people who play games and take them seriously and all this other stuff. If you're editing a document in Microsoft Word and it takes an extra, tenth of a second for your document to save in the cloud than somebody else's you're probably not going to notice, right? So, so just from a memory management perspective, we might have to deal with those two operating systems differently. Not so much the ultimate goal, but keep in mind that the memory manager on a desktop operating system only needs to handle requests to load things from the hard drive into real memory from one individual, one user at a time. We could even take it a little step further and give the desktop operating systems the benefit of the doubt and understand that, okay, well, technically our machines today are dual and quad core machines, and they can actually do a little bit more than meets the eye, blah, blah, blah. So maybe you have some software applications running in the background, and maybe up to 4 of those applications at a time in a quad core could potentially be requesting for something to be loaded into memory. So in our modern desktop operating systems, you can think of them as kind of small little servers, where they only need to be able to handle up to 4 simultaneous users for very specific tasks. That kind of makes sense? But that doesn't get us anywhere near to the number of simultaneous users Google is having to support. Right? Totally different world. So now we need to start thinking about who gets priority for loading things into memory. Who's the most important user? Who gets priority when they do a web search at Google? Well, if you're doing a web search, you want priority, right? Skippy's doing a web search, he wants priority. Everybody wants to be number one. They want to feel like they're getting 100% priority. Who actually gets priority? How do you think it works? Is there first come, first serve? Let's say the answer is probably yes. Why? Why do you suspect it is first come, first serve for doing a Google search?
Because wouldn't it have to stop their current process and go back to what the new process would be?
Well, I'm thinking let's just say 30 people are all doing a Google search at the same time. Relatively the same time. They probably clicked the button, and their requests showed up in some sort of order, but all right in a row. Why do you think that Google probably needs to deal with those as a first come, first serve basis? They need to use the McDonald's get in line algorithm for handling those searches. Even though Google servers are doing it really, really, really quickly, so those people don't necessarily know. It's not like waiting for 3 people in front of you who are ordering, food for a T-ball team. It should be quicker than that. But why do you suspect that they probably need to solve that problem as a first come, first serve? When you do a Google search, do you log in or anything? It's completely anonymous, right? They can't distinguish one person from another for who's an important searcher versus who's an unimportant searcher. Correct? There's no way to do it. Now they can probably take some liberties and maybe do it based on location or something like that. Like, maybe, people in, let's say that Google has a Russian. Maybe they like the Russians. One of their owners, Sergey Brin, has a Russian heritage. So let's just say they're pro-Russian. Those commies. switching over to Bing. I think he's a naturalized citizen now.
It's B-A-I-D-U.
Yeah. But let's just say that they want to give the Russians the advantage when it comes to Google searching. Okay, so they can maybe do it based on location, where the searches are coming from, and give priority there or something like that. They probably don't. Well, it probably accidentally happens because Google likely has server farms regionally. So probably when you do a Google search here in the Midwest, you are probably only competing with Midwest United States searches. because you're going to Google's server that's closest to you. Let's just use that as a probability. I don't know exactly how Google's behind the scene infrastructure works, but if I were creating an infrastructure that had to support that many users simultaneously, you're probably not going to have a single computer sitting in Sergey's basement, okay, in Cupertino, California, running off a DSL line that's handling all Google searches worldwide. Probably not the way they're doing it. So it's got to be somewhere in the middle. So one possibility is everywhere you go, there's a Google server sitting right next to you that just does the search, which would actually be interesting if they offloaded. Actually, Google probably does some of that from a performance perspective. And when we start talking about distributed operating systems, we'll come back to that, come back to this little comment. But if you consider that several things that you might do on a website are time consuming. So here, just real quick, this is the reason that something like JavaScript exists. Most of the use of a scripting language like JavaScript for web pages is for form validation, to make sure that you filled in all the information required before you submit something to a website. That's most of the reason JavaScript exists. Let's just throw that out there. That's probably the biggest reason it exists. So if you are filling out a credit card application online and there's 30 fields that you need to fill in, JavaScript will check to make sure those fields are all filled in, all the required ones, before it allows you to hit the submit button. Why? JavaScript runs locally. It can check all that stuff using only your local computer's horsepower. And only once you've actually filled it all in, and it said, okay, you passed the pre-check, will it actually allow you to send your data up to the server and waste their horsepower. Does that make sense? So you can actually take some of that computation locally, so you're not bogging down servers with errors or with like unfilled out forms. Yeah.
What about PHP?
PHP server side.
Doesn't that do the same thing?
No, server side.
Okay.
So PHP, if you relied on PHP for form validation, that means every single time you hit the submit button with those 30 fields, if you filled in one field and say, give me my error, filled in another field, give me my error, it's sending it to the server is saying, I don't have enough information, and it's spitting back an error message. So you're putting all the burden on the server in the cloud. Where JavaScript, you can handle most of it locally and not even burden the server until you at the very least filled in the form. Whether it's reasonable information or not, it's a whole different story, but you at least filled it in. So when we talk about distributed operating systems, we'll talk about kind of, moving the burden of computation out onto the clients. But right now we're still talking about, the kind of the black and white issue of I have a computer I'm sitting right in front of, and this guy's meant to give me everything that I need. Versus I have a computer sitting in the cloud somewhere that is meant to give me and my 4 zillion friends simultaneous searches. Those are two very, very different problems. So, in any case, we want to start thinking about how an operating system decisions when it comes to memory management. And it gets even more important once we start getting to CPU management. So now, memory is one thing, but now you have 4 zillion people trying to share a quad-core processor. If you go to Dell and you configure a Dell server, a normal, hey, I'm a medium-sized business and I need a server for my business, it's probably going to be running a quad-core processor or a dual quad-core processor, maybe as much as a dual 6-core processor or something like that. Not what Google has. It's going to be kind of like awesome for like a business of 20 people, but not what Google has. So if you're running that and you have 20 people who are all trying to share 4 processors, depends what they're doing for how you have to manage those processors, how the server operating system needs to manage it. Kind of make sense? All right, we'll come back on Friday and continue this conversation.